Hi, Joe Cerrone.
And Alan Rosen.
Welcome to CAD 117 Intermediate AutoCAD and our Zoom classroom meeting number 2. Alrighty. So as we take a look at our upcoming events, Module 1 is due at 11:59 tonight. And as you remember, Module 1, under the content section, was to create these drawings right here, these two drawings right here. Continuing back to the main splash page, we're going to be working on Module 2. Module 2 works with multi-view drawing and 3D modeling. And so as we take a look at multi-view drawing and 3D modeling, we're going to create the 2D drawings this week. And then next week, we're going to do the 3D models. And so as we look at the outline of topics, part 1 is going to be due 11:59 on October 5th. And then part 2 to model the parts is due the following week. And then we'll go into module 3. As we look at module 2, we can see that we have this already laid out for you. Here is the lecture. And so if we click on the lecture and we open that, we'll go through the content for multi-view drawing. And multi-view drawing is really two-dimensional drafting on a board or using AutoCAD for two-dimensional drawing. And what we're looking at is what multi-view drawings are and their importance, the views and how to align those views in multi-view drawings, being able to visualize and decide which views to use, and then some of the standards for line types and line weights according to ASME, American Society of Mechanical Engineers 14.2. In the United States, we use third angle projection. And then as we look at the way to create these, we'll use a miter line to create these different views in two-dimensional views. And then it talks about things like how you view objects that are 3D and 2D. And so they give this bus example with the front view, top view, bottom, right, and left side view. And this would be considered multi-view drawings. Same thing with this house. The way this book is set up is that we do both architectural, or we draw both architectural and mechanical drawings. And so again, here's our front view, our right side view, it's in top view. And then notice that everything is lined up. So the bottom line here lines up, the windows all line up. And so the idea is that we can go through and transfer dimensions from one view to the other. And that's what a lot of basic engineering graphics starts with, just being able to go and figure out what this object looks like in 2D. And really 3D modeling is a much better way to go than it was back in the day when we were drawing with paper and pencil. And so being able to visualize what the front view, right side view, and top view look like, being able to understand how hidden lines, center lines are drafted properly. It does talk a lot about true size, inclined views, and things like that. But that's really not as big a thing as it used to be, because prior to CAD, you'd have to calculate out the true size of all these things. But with CAD, we can computer model it, and we can always get a true size view, depending on if we are able to go parallel to the view, perpendicular to the view of projection. And so they do show these techniques, these older techniques for drafting, where you would take each point and project it up into the view to get these different views of the drawings. And then they talk about how oblique surfaces are not shown in true size in these different views. So some old school traditional drafting techniques and some terminology for those different techniques. And then the way that you would go through, what they used to do is they would remove one of the views and have you draw, and they'd give you two, and they'd have you figure out what the view that's missing would look like. And it was quite a bit of work. You'd have to go through and number each of the vertices and translate all the drawings. So these are these multi-view projection techniques. And then we get into the CAD terminology with visible lines, center lines, extension lines for dimensions. And so the vocabulary should be on your list of things to learn as we go through and work with technical drawing skills. And they also go through things like, visible lines will show the visible edges. Hidden lines will show features that would not be visible. And then center lines locate things like the centers of circles and holes and things like that. And then in the day, we used to go and send people to the bookstore to get a drafting set, and you would get different drafting mechanical pencils with different line weights or different leads for the different line types. Because as you look at the drawings, these are the standards that we use to draw those lines. And so visible lines will be thicker at 0.6 millimeters, hidden lines at 0.3, center lines at 0.3, and dimension lines at 0.3. So as you go through and you create your drawings, the object lines will be heavy and dark. The hidden lines and the center lines will be thinner. And then the dimensions will also be thinner. And so it's easier to read as you go through and you create these drawing views. And so we go through these visualization exercises, and that's really the key point to this drawing exercise, is that we'll create front, top, and right side view of these simple shapes, and then we'll model them. Notice that we have center lines. A lot of people leave the center lines off. Center lines mark the axis of symmetry or the centers of rounded features. And then this is the technique for translating the dimensions of height and width and depth from one view to another by taking front view to top view, bouncing it off of a 45-degree miter line to the right side view, so that this dimension right here, or the depth, is the same as the depth over here, and the height is the same as is over here. And so this is the standard for orthographic projection. And then it's just a matter of figuring out which view to select and begin drafting. Talks a little bit about scale, being able to draw to full scale, half scale. With CAD, we always draw to full scale. And then what we do is we set the viewport scale to be able to scale it within the viewport, so that when we print it out on a plotter or a printer, we can measure the CAD drawing with a architectural scale or with a regular engineering scale. Paper sizes, as you go through and you work with paper, when we used to have drawers full of paper and we'd have to go through and lay out drawings, you'd kind of have to calculate out the scale of the drawing to see that it would fit on the paper, and then you would pick what size paper to use. And it doubles in size. So A size is 8.5 by 11, B is 11 by 17. So we carry over the 11 and then we double the 8.5. And then C size would be 17 by 22. So we carry over the 17 and double the 11. More on first and third angle projection. And then our summary. And so we'll be working on these different drawing exercises for multi-view drawing. We will draw these different figures here in 2 dimensions, starting with the front view. And then we'll draw the right side view and the top view, and we'll include hidden lines and other things like center lines for that. And so to get to this assignment, what we'll do is we'll keep this on our second monitor. We'll print that out, and then we'll download the grid sheet. We can go over here to the home page, select this, open it. And so here's our grid sheet. And then as we go through and we look at these different figures. Here's our multi-view part sheet. And you just have to count grid squares. Whoops. How did that happen? So as we look at these grid sheets, we can go through and count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I'll start with something that's already started. We would draw a line 10 units over. And then we would draw that line 3 units up, 3 units over, 3 units up. And these would be drawn on the visible line layer. Hidden lines would then be drawn on the hidden line layer. So this line right here would not be directly visible in the right side view. So it would be drawn as a hidden line. And then this would be our height. And you can always kind of bounce things down and around. And so as we look at the drawings that we'll be creating, we'll create them as shown here. We'll create this cylindrical shape. The first circle is going to be 1 square as a radius or 2 as a diameter. And then the side view will be 1, 2, 3, 4, 5, 6 units. 1, 2, 3, 4, 5, 6. And so we'll continue to create those drawings. If I was to create the right side view here for this one right here, what I would do would be I'm not sure if I'm going to be able to pull this off. It doesn't quite have the information, but we'll give it a try. And so I can go to the visible line layer, create a line, and we can start at this corner right here. And then we can go over 2 units, go up 1 unit, go over 2 units, go down 1, go over 2 units, hit escape. And then as we create the arc for that, I'm just going to draw it with the circle from the center. And I'm going to trim it. I prefer to draw circles and trim them than I do to draw them with arcs. And then our right side view be 6 units. And it would look like a square. We'd switch over to the hidden line layer. And then we would project over the hidden line from here. And then in the top view, we would look like a square also. And so it would be. And I'm on the wrong layer. I can fix that. To fix that, I can select them, go to my layer, and make that on the visible line layer. Hit escape. Use my hidden line layer. to project up, that feature goes all the way through. It looks like I'm a little off. I don't think it will delete those. I think they're on a locked layer. Let's see. Oh, they did. You can lock that grid layer out. And then if you have to make some changes to it, you don't have to worry about getting the grid. And then make sure that you remember to add the center lines. And so I can either use the annotate, center mark, and then clean this up a little bit. You don't want lines on top of lines as we go through and we work with this. I don't think it will let me with this new automation, so I have to actually grab these grips. And they're constantly improving, you know, the CAD software. We want this to be somewhat symmetrical. So we can put our center line there, and then we can just drive a straight center line. I think it's easier to just draw it. If you're getting the O snaps, sometimes you need to turn those off. I'm going to leave polar on so I make sure it's straight. And so we'll go through and we'll create the CAD two-dimensional drawings of each of these different shapes. There's a video that shows you how to do that in D2L. So if we go to the content section, module 2, here's our lecture, PowerPoint, here's our grid sheet, and here's our video on how to do the exercises. And so we kind of walk you through how to create each of those different exercises using a miter line. It's a little bit of a different version, but the technique is exactly the same. So I don't think it's really necessary to redo this video. Not at a fundamental level like this. Here's the exercise files. And then in the PowerPoint, in the main splash page, there's additional drawing models. So if you're looking to do more and more work, there's plenty of additional work to do. And then we have some introduction to 3D, which we'll cover next week in part 2. All right. So that's the basic exercise for module 2. I'm going to come back here to the main splash page. Al, is there anything else that we need to touch on before I stop the recording?
Maybe we go back to AutoCAD for one moment, please, Joe. And pick on one of the drawings. That's fine. And zoom up on the top side view. One of them doesn't make a difference. If for some reason your lines don't look like they're hidden or centered or dash or dot, what's the main terminology or what's the command you need to change it so it looks like it, Joe?
Are you talking about the LT scale command?
That's correct. What does that do for us?
It sets the scale for the line type. And I think they're okay at 1, but if, let's say we doubled it to 10, or we made it 10 just to show the difference, you can see that there's very little gap. And then if I go to 5, 2, 1, and then we could even go 0.5. And then as you can see, it makes them much more finer. But this one's set up for full scale, so a LT scale of 1 is fine.
Great. Thank you very much.
Alrighty then. So with that, go ahead and complete those drawings and then submit those to the module 2 Dropbox. And then next week we'll go through and create some of those 3D computer models. All right, so I'm going to stop the recording and open things up for questions.